Hello, wonderful people. Okay, so here we are at the start of Chapter 7, Momentum. We're just going to cover Section 7.1, which defines the term, and we'll call that good enough for today. So, Desiree did this some years ago. Oh, that's why it has nice animations. So, what is momentum? Momentum is the product of an object's mass and its velocity. That's the definition. Now, because velocity has both a speed and a direction, that means momentum also has direction. And anything with a direction is a vector quantity. So to be completely correct, there should be a little arrow above the V for velocity there, and also one above the capital P for momentum. Oh, speaking of which, 300 some years ago, when Isaac Newton was first figuring this stuff out, he didn't use the word momentum. He used the word impulse. So when things changed and we started to use the word momentum, we did not change the letter, mostly because there's so many M's already. Miles, meters, mass. There's just too many M's. So we decided to keep P for momentum. Okay, so let's break down that equation. I just did that. P for momentum, M for mass, V for velocity. V is a vector, and momentum equals mass times velocity. What's next? Question. I hit it too fast. What is the momentum of the car below? There's the car with little Mr. Gold Alien in it. All totaled, that weighs 50 kilograms. And they are moving along at 10 meters per second. So what is the momentum? Mass times velocity, 50 kilograms times 10 meters per second. So we get an answer of 500 kilogram meters per second. Now, we do not have a fancy little abbreviation for kilogram meters per second. I suppose it would be momenta, or we could just pick another famous scientist and name it after him. But we haven't done that. So we just stick with kilogram meters per second. Then what? Come on, animation. Oh, I'm not going to wait for that. Can a big, slow moving object have the same momentum as a small, fast moving object? Yes, absolutely. You just have to fiddle with the numbers. So if I've got a 1 kilogram object moving at 1 meters per second, it has 1 kilogram meter per second of momentum. Now, if I cut the mass by a tenth, then I just have to up the speed by 10 times. 10 times 0.1 still equals 1 kilogram meter per second. Capiche? Conservation of momentum. Are we going to go into that? I'll just mention it today. So there it is, stated in nice, clean language. As long as there are no external forces acting on the system, the total momentum of any system of objects interacting with one another remains constant, regardless of the nature of the forces between the objects. Wow, that is not clear at all. So there's impulse. Okay. We won't cover conservation of momentum today. I would have liked to have cleaned that verbiage up quite a bit. So that's it for 7.1 today. There's a few homework questions. They are just as easy as those problems right there. Okay, good luck. Thank you so much. Have a great day.